Hello everyone, my name is Jonathan Robles and today I'm going to talk about work that is on the inhibition efficiency prediction based on global molecular descriptors within conceptual density functional theory. And well, in this work we want to know if we can predict the inhibition efficiency using molecular descriptors. And well, to begin, it's important to mention that exist two results that are really commonly used in this kind of studies. One of them is that the inhibition efficiency is going to increase if the electron donating ability increase and its value is lower than 3.6. This is one result published by Lukowitz. And the second one is that, well, the inhibition efficiency is going to decrease if the HOMO-LUMO gap is higher than 1.3 betas, that is the unit that they report. And well, it's going to decrease if the value of HOMO-LUMO gap is lower than 1.3 betas. And well, we want to know, if we want to make some robust calculations about this because, well, Lukowitz, to obtain these two results, use Huckel molecular theory. And we want to reproduce these results but using Hartree-Fock and density functional theory and make a comparison between our results and their results and know if these two results reported by them are true or how can we improve these results. And well, the methodology that we follow is the next. Firstly, we optimize the molecules with genetic algorithms. In this case, we use the software Balloon. Secondly, we optimize the molecules using Gaussian and devices DFT, TCBP. And well, we use two methods. The first one was Hartree-Fock and the second one was density functional theory with two different functionals, PBE and B3LIP. After that, we obtain the molecular descriptors and finally we obtain mathematical models and, well, the mean absolute percentage error in comparison with an external dataset in order to know if these results are correct. And well, to begin with the results and discussions, we can see the figure 1. In the figure 1, we can see the next. For density functional theory and the functional PBE, we can see that inhibition efficiency increase for a higher value of electron donating ability. And well, but for Hartree-Fock and for B3LIP, we cannot find a relationship between inhibition efficiency and electron donating ability. Only have this weak relationship between inhibition efficiency and electron donating ability using PBE functional. Well, this is what was one of the results that we obtained. So we cannot conclude that this result is true. And the second one that is important is that all the values are always lower than 3.6 for the electron donating ability. This is important because, well, this is one of the statements that Lukowitz proposed, but always is going to be lower than 3.6, this value. And well, for the figure 2, we can see that for HOMO-LUMO gap and inhibition efficiency, we cannot find any correlation between these two values. And well, this is important to mention because we cannot find any relationship between these two values, these two variables. And well, what was the thing that we proposed? We proposed to use artificial intelligence. In this case, we use Watson, artificial intelligence, in order to know if we can obtain a correlation between molecular descriptors such as electron donating ability, electronegativity, hardness, HOMO-LUMO gap, electrophilicity, and another ones. So using Watson, we found that for PBE, all these values are important. Energy of orbital HOMO, energy of orbital LUMO, electrophilicity, and electron donating ability. For Hartree-Fock, the most important variable is the energy of orbital LUMO, and for B3LIP was the electrophilicity. Considering this, we predict the inhibition efficiency for an external data set of molecules, and we obtain the next results. In the first two columns, we can see the values obtained for Hartree-Fock and for Beat-Relief, because have the lowest value of MAPE, mean absolute percentage error, and inhibition efficiency reported in the last column is the experimental value. And well, we always have to have a portable model, but we try first with linear models, but the mean absolute percentage error was so bigger. So in this case, we propose to use non-linear models in order to have a better approximation for the inhibition efficiency. And we obtain the next results. For Hartree-Fock, we can obtain a model of second order using electron donating ability to obtain the inhibition efficiency with a MAPE around of 9.32. This is interesting because we can predict inhibition efficiency with a lower value for MAPE, well, for a lower value of MAPE, and this is a portable model. Anyone can use this model, only knowing the electron donating ability. And the second model with MAPE around of 9.37 was the next, using energy of orbital LUMO. Finally, for the functional Beat-Relief, we obtained the next two models of third order. These models were obtained, such as Taylor series, in order to approximate the inhibition efficiency value. And well, we obtained these two models of third order. And the best mathematical model that we obtained was this model, the model of third order, using the functional Beat-Relief with a MAPE around 7.79. And the conclusions that we have is that, well, we cannot conclude that exists a relationship between the HOMO-LUMO gap and the inhibition efficiency. This is the first important point to highlight. Another important point is that, well, we can obtain mathematical models to predict the inhibition efficiency. This is important to mention. And, well, we can optimize the molecules in different ways in order to know if the electron donating ability is correlated with the inhibition efficiency. And we only obtain that, well, maybe for a PBE way to optimize the molecules can exist a weak correlation between these data. And well, that's it. We want to thanks to the Tec de Monterrey and the UNAM for the support in the development of this project. Thank you so much.